Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. The cement industry has been working on decarbonisation for many years using three traditional levers, energy efficiency, fuel switching or AFR, and clinker factor. And today I'm talking to Dirk Lechtenberg, who's Managing Director of MVW Lechtenberg Partners, who are experts in AFR and WCA member. Dirk's also Director of Blue River Recycling, and we'll get on to both of those companies in just a second. So Dirk, welcome. Perhaps we could start by getting you to give a brief introduction to yourself and how you came into the cement industry.
Yeah, Ian, thanks first of all for your invitation to participate in your famous podcast. I'm Dirk Lechtenberg, as you said, the founder and managing director of MVW Lechtenberg and Partner, located in Duisburg in Germany, directly at the River Rhine. I started my career in a daughter company of a cement plant here in Germany, Liebach Cement or Portland Cementwerk Wittekind, which was the pioneer in processing alternative fuels. At that time, it was named Fuel from Waste. So it was the first company in Germany and therefore worldwide, which was intending to process waste as an alternative fuel source. And since then, I'm working in the cement and lime industry, but mainly in the cement industry, where we are developing projects, calculating projects, how to process waste and biomass into alternative fuels, and how to introduce such alternative fuels in cement plants worldwide. And this we are doing since, I'm doing it since almost 30 years. And we have developed so far, more than 200 projects worldwide, from Australia to here in Europe.
So I think MVW are well known in terms of their expertise in alternative fuels, and
Thank you.
I'm sure a lot of that comes down to you, Dirk. But I think you have some partners there as well. Yeah?
Yeah, we are a team. We're a team currently, almost 20 people. Most of them are working with us since many years, but we are currently expanding our team due to the needs in the cement industry for decarbonizing.
And can you just explain who are Blue River Recycling?
Yeah, in the last 10 years, more and more cement groups and cement plants asked us not only to consult and advise them, they asked us to take over the processing of waste and deliver the alternative fuels directly to the flame. That was the reason why we developed 4 years ago, a daughter company, which is fully owned by us, by our family, where we are processing mixed waste, separating the recyclables, and processing the high calorific valuable materials into pelletized fuels, which we are supplying currently mainly to the German market and Sweden. But we will build another 3 facilities here in Germany to expand this.
And how do you see that that business developing, Dirk? I'm wondering if you expect there to be an impact from the fact that everywhere we look, people are trying to reduce the amount of waste they're generating. And so the nature of waste is going to change over the years.
Yeah, we hope so, because as we can see in developed countries, we are producing each year more and more waste. When you look at the European Union, last year more than 18 million tons of plastic was produced and wasted. And there are a lot of projects going on and regulations in order to avoid the production of plastics or to recycle the plastics with new technologies such as chemical recycling. However, we see also the demand in the cement industry and other energy-intensive industries by substituting fossil fuels with defined alternative fuels.
Yeah, so maybe we can touch on the trends in the industry and new alternative fuels a bit later on. But can I ask you first, let's explore a little bit the difference between biogenic and non-biogenic alternative fuels, because as we start to see higher carbon prices, then obviously the way those are treated is a little different.
Yeah, that's a very interesting topic. I just looked at the today's carbon price in the European emission trading system, and today is 103 euro per ton of CO2. It was, as you remember, 25 euro beginning of last year, so a tremendous increase. And this will lead to a change in the composition of alternative fuels. The biogenic content, the biomass content, mainly derived from organic waste, but also paper waste and textiles, wood, are so-called the biogenic content within the alternative fuels or refuse-derived fuels. And the cement industry is looking to change the composition of these alternative fuels in order to increase the content of such biogenic materials, which count for the emission reduction. The calculation or the analysis of the biogenic content is done by regular analysis, where the organic particles are separated from the fossil fuel-related particles like plastics. And this has to be reported to the national agencies of the governments here in Europe. In Germany, it's the Deutsche Emissionshandelsstelle, it's the Federal Environmental Protection Agency. And these reports have to be checked and audited as well. So the whole industry now is trying to increase the biogenic content to reduce their CO2 and carbon footprint.
So just to be clear, especially to our listeners outside Europe, then within the ETS system, if you're burning a biogenic fuel, the CO2 is not counted as a CO2 emission. Is my understanding there correct?
Yes, that's correct. It's not counted as a fossil CO2 emission. The reason is quite simple. If we are using fossil fuels which were generated thousands of years ago, like coal and oil, and the biogenic content of such waste like biomass is just produced within the last decades. So it's within the CO2 circle, and therefore they're counting it as carbon neutral.
Yeah, and then of course when you when you think about carbon capture coupled with the use of biogenic fuels, then you get this effective removal of carbon from the cycle, which of course, depending what you do with it, can attract some quite attractive offset prices.
Yeah, that's correct. And with this high CO2 prices in Europe, we are now at the edge that even a carbon capture system can be economic.
So in terms of the measurement to differentiate between the biogenic and the non-biogenic, is this something that the cement plants themselves are responsible for doing, or is this something that is administered by the governments in the EU?
No, the reporting has to be done by the cement producers itself, not only for the fuel-related emissions, also for the product-related emissions. So depending on the amount of alternative raw materials and alternative fuels and other energy efficiency measurements, cement plants can reduce their CO2 footprint.
And are the measurement methods available considered to be accurate, or is there a degree of uncertainty in those measurements?
According to the European emission laws, there's a strict regulation how to measure the CO2 emissions and how to report the CO2 emissions. So, for example, a cement plant which is using 100,000 tons of refuse-derived fuels or alternative fuels a year has to make a full declaration analyze every 5,000 tons. And based on the biogenic content of all these analyses, they are reporting their CO2 emissions. But again, it will be audited by a third-party auditor and then again checked in the national authorities which are monitoring the emissions.
Right. So a pretty robust system there.
Yeah, but still there's some room for some problems, such as how to take the sample. Is the sample correctly taken? Therefore, we are in discussions with the German authority to automate this process by installing new technologies for measuring the biogenic content in the RDF, for example, by near-infrared systems or by RFA analysis, in combination with the C14 analysis of the clean gas which comes out of the stack.
When I was working for Holcim in China, we started to use municipal solid waste, so sort of the whole of municipal solid waste as an alternative fuel. The metals and so on, well, the valuables, you could say, metals and indeed PET and so forth had already been taken out of it. So there was a very high proportion of organics, essentially kitchen waste, in the waste, and very high moisture contents, which of course is a big challenge. I think in Europe, historically, that has been separated, hasn't it? And I think mainly composted. Is that right?
Yeah, that's correct. It's a big challenge for the cement industry. And in regular meetings with our clients, for example, in Asia and India, in the Middle East, they're always asking why and how is it possible that the cement industry, for example, in Germany, Austria, Poland, is reaching 70, 80, 90% substitution rate. It's very difficult in developing countries where there is no separate collection of the dry waste and the organic waste. So the cement industry in Europe especially has a big advantage that there is a system for the separate collection and that there's a complete infrastructure for the waste management, including recycling facilities, including companies which are processing the mixed waste into or industrial waste into alternative fuels.
Do you think that with the additional value of biogenic fuels, whether it be in terms of reduced fossil emissions or potentially combined with carbon capture in terms of valuable carbon offsets, do you think there is any possibility that some of that organic waste that has previously been composted will be burned in as alternative fuels instead?
Yes, there are a lot of discussions ongoing, and even we are doing tests in Saudi Arabia, hearing right, in Saudi Arabia, in a country with the lowest fossil fuel prices. We have been developing already a project and developing further projects as waste management solution. And the idea is to take a part of the organic waste, to dry it with ambient air, with bio drying, or even with the available waste heat from the kilns, to provide a fuel with a lower calorific value, but with a very high biogenic content, which allows the cement producers to reduce their CO2 print significantly.
Yeah, and is that something that you see happening in Europe, or do you think that the collection systems are already well enough established that they don't change?
In Europe, it's a bit different. Yes, the cement industry is thinking how to increase the content of biomass in the alternative fuels. But most of the kilns in Europe are preheater kilns, so all the fuel needs to come through the main burner. And the main burner requires a minimum calorific value of, let's say, 4,500 kilocalories, which you can't reach with such organic materials. So the advantage is mainly available in cement plants which have a calciner and which have the possibility to increase the organic content in their RDF step by step.
So other than the biogenic fuels, what other trends do you see in alternative fuels such as hydrogen or other fuels?
In principle, all over the world, cement companies are trying to increase their substitution rate or starting with alternative fuels. You have to see one side of the world which is starting with alternative fuels, and the other side, like here in Western Europe, where you already have a very high substitution rate, and companies trying to optimize it and trying to substitute or change the remaining 20-30% of fossil fuels with, for example, hydrogen. But these are all pilot projects, which will take some time as there's not enough renewable hydrogen available at the moment. Secondly, a lot of companies are trying to optimize the consistency of the alternative fuels into a fine grinded material that can be used in the existing coal feeding systems to completely eliminate the fossil fuels.
So going back to Saudi Arabia, which you mentioned earlier, I wonder if you see different trends in Saudi Arabia or elsewhere in the Middle East or North Africa and the Middle East.
Saudi Arabia is an example for the use of alternative fuels because it's forced by the government. The government is trying to develop a sustainable waste management system, and they know that the cement industry has the ideal conditions to support a country in solving a waste problem. So it's not in order to reduce the amount of HFO, of heavy fuel oil. So main focus is developing a sustainable waste management and reducing the carbon footprint. Within the Vision 2030, the government wants to reduce the carbon footprint significantly.
Yeah, so that's interesting, because that was also the driver in China of adoption of alternative fuels, and particularly municipal solid waste, was because of the phasing out of landfills, and pretty much the impossibility of opening new landfills in heavily urbanized areas. The government initially turned to incinerators, but the incinerators, because they developed a reputation, deservedly so, I think, in this case, for hazardous emissions.
Yeah.
They generated a huge amount of resistance from the locals. Whenever an incinerator project was announced, there were immediately locals sitting in the street, blocking the way and all this sort of thing. And so the cement industry provided a safer alternative, and indeed a cheaper alternative to incineration. And I guess it's interesting that in Saudi you see the same trend. Is that something you also see in India, or do you think the drivers in India are a little bit different?
Yeah, the original driver was the same. The Indian government has published some legislations a few years ago that every cement plant has to support the virginity, the municipalities and the virginity of the cement plant by taking alternative fuels, so by processing waste. We also see as trend overall that the co-incineration or co-processing of waste in the cement industry is more favored than typical waste-to-energy facilities, for two reasons. Firstly, in a waste-to-energy facility, you are burning all the waste. You are not separating the recyclables, and you are burning all the waste. You need a very massive investment. The capex costs are very high, the operating costs are very high, and you're still remaining with 30% of slag and ashes, which you have to landfill, and the flue gas cleaning residues, which are hazardous and needs to be stored in designated hazardous landfill areas. Whereas the cement industry has the possibility to support the circular economy by separating all recyclables and using the remaining clean materials under very high temperatures, ideal conditions, and the ashes are combined into the clinker matrix, so are even saving fossil raw materials like limestone.
So one of the questions that is often asked is, with an incinerator, the bottom ash in particular has a concentration of heavy metals and other undesirable elements. Why is that not a problem when we burn the same waste fuel in a cement plant?
Yeah, because we are not burning the same waste fuel. The cement industry has very high requirements regarding the quality of the cement. It's a standard product. So the industry has to secure that there are no elements coming into the product which has a negative impact on the product, like zinc or other materials. And again, which doesn't have any negative impact on the environment. So all the waste is separated, all the waste is processed, and only a small fraction of the municipal solid waste can be used directly as fuel in a cement plant.
And you mentioned the role of temperature. This is also helpful in avoiding some of the harmful air emissions.
Yes, this is one key factor. When you look at a typical waste-to-energy facility, the incineration temperatures are between 850 and 950 degrees Celsius. And in a cement plant, you have temperatures at the flame of 1,400 degrees. And when you compare it with hazardous waste incineration plants, they need at least 1 second temperature with 1,150 degrees. So the cement industry is providing even better conditions for this.
Right. So if we look forward to new technologies in alternative fuels, are there new technologies, either the fuels themselves, I think we probably covered, but in terms of the way in which fuels are used, are there new technologies that you're excited about?
Yeah, especially the gasification. We're involved in a few projects where waste materials, separated waste materials, are gasified and the gases are splitted. So from the gas, you can produce through a water shift process some hydrogen, but you can also use the heat and the low quality syngas as substitute in the lime and in the cement industry.
So this is one technology associated with gasification. Do you wind up? Is that starting with a pyrolysis process? Is that the way that you start there?
Yeah, it's a kind of pyrolysis or gasification process.
Yeah. And do you wind up with a residue of, I don't know, biochar or carbon or something like this?
Depending on the raw materials, I'm speaking about the processing of low calorific value materials with a higher biogenic content, which can be gasified into a low quality gas, which can further process to separate hydrogen and using the remaining in the cement. Yes, there are processes for tires, to process tires into oil and so-called carbon black. But so far I didn't saw any tire pyrolysis plant which were producing a quality of carbon black which was accepted by the tire manufacturers. So in many cases, like in Saudi Arabia, in Jordan and other countries, this so-called carbon black is even used as fuel in a cement plant. So for me, there's a question why first separating it, putting it into a pyrolysis while burning the residues anyway in a cement plant. So you can even put the tires as they are in a cement plant.
Dirk, so if we just think about the challenges that cement companies face in using alternative fuels, and obviously in many companies they already have quite a bit of experience of this, but there are companies in some parts of the world that are just starting out on this journey. Do you have any words of wisdom that you'd like to share with them on the start of that sort of journey?
Yeah, I think that the most important point is to have the right equipment for the quality control, storage, doors, and feeding. In many developing countries, the cement companies are hesitating to install such equipments because of the cost. And they're always stating we don't have secured fuel supplies for the RDF or for the biomass. So if a cement producer is providing such feeding system, there will be automatically a market development in the local waste management, in the agriculture business, and the plants can secure the supply of fuel step by step. This is what. And secondly, trying to have a good team in the cement plant which understands why the cement plant is using alternative fuels. It's not only to save costs, it's mainly for the society, for the team members and for the employees in the cement plant to secure their working place and doing something good for the environment and society.
Yeah, so thank you for that. I think that's excellent advice. I recall the advice on making sure that you have a strong team is something that we see running through many of the podcasts that we've been doing recently. And it's a real resource. Your employees are a real resource, especially when it comes to dealing with things that benefit society, because, we all live in society and care about it. So thank you very much for that advice, and thank you for speaking to me today, Dirk.
It was a pleasure. Thanks, Ian.